Okay. Today we've got Dr. Patrick Almer, who has a PhD in computer science from Temple, the AI track, and he did a lot of work on NARS. I first saw Dr. Almer in 2016 in New York at the AGI conference, and he's a postdoc at Digital Futures. So without further ado from me, Patrick, why don't you go ahead? Thanks.
Thank you very much, Mike, for this great opportunity. It's amazing, and I think it's the right time to make the overall AGI approach more mainstream and to try to make major progress towards the goal which we all share. And today we will particularly talk about a particular project which we have been carried out here in Stockholm, which is to combine NARS, so the non-axiomatic reasoning system, which was proposed by Professor Wang here, and we try to combine it with some recent technology which has gotten widespread attention, which is GPT models, which are really capable to deal with the complexities of human language. And there is, of course, the question: can we build systems which can reason and remember knowledge over a long time period and update their beliefs? And can we have systems which can do this? And to some degree, many of these capabilities have always been a part of the non-axiomatic reasoning system. And together with GPT, we can make this technology more approachable to everyone in the world by providing a way to interact with this reasoning system with natural language. And to some degree, of course, also GPT itself has some capabilities which has gotten widespread attention for very good reasons. It's, for instance, not immediately clear how much reasoning capabilities can be reached with GPT alone. And today we will see some of the limitations. So let's dive right into it. But first, I want to give a small acknowledgement to our collaborators, which have really supported us over the years, especially Hugo Latterby, with who we work together very closely with Cisco. And then there's also Julius Prammer from Fraunhofer Institute in Germany, who has carried out a large part of this project together with us. I also want to give special thanks to Peter Voss, who has developed and evaluated part of the system together with us and has provided a Q&A benchmark to us, which really shows long-term incremental Q&A capabilities. And in addition, I also want to thank very much my postdoc advisor, Robert Johansson, who has also carried out very promising experiments with the system, and which soon we will have some papers published which really show the capabilities which we have with combining these technologies. And here I now want to just give a brief motivation, or maybe first the overall structure of the talk. So we will talk about how much closer did we get to intelligence with what happened recently. How does NARS play into this, the implementation of NARS, how we can combine it with this generative pre-trained transformer models, which are so successful recently, and various approaches to do this will be shown, and experiments and results which we have obtained in this direction. Last, we will give demos and will provide major takeaways before we will dive into the Q&A section. And I will now give the motivation, which is what do we want to achieve? And that's not an easy question in the AI field. After all, there's no common accepted definition of what intelligence is. There are so many different views of what it is, and there are some definitions which have been widely accepted. We will see one of them which has gotten widespread acceptance by the community. And for this project, we especially want to have a system which can remember information for a long time and use this information to reason on it and derive further information, which it can then make use of at a later stage when it becomes important to make decisions, for instance. And there are some challenges involved in this. Ideally, we want the system to be able to learn incrementally. We want it to give it additional information, and it should absorb it, and it should not forget it. It should be able to build on it, essentially. And that's not an easy goal. If we look at current limitations with ChatGPT, for instance, we have this issue with the limit contextual window, which is, even though it's a few thousand tokens, that's really not much. This means if you have a few thousands of sentences, then you are already out of the contextual window, and it will already begin to forget what was written at the beginning. And more recently, there have been advancements like with vector databases, so that essentially you can calculate embedding vectors of the sentences and then later pour in the related information using these embeddings based on vector similarity. We will see some approach which we have explored in this direction and how we integrated it with the overall system. For us, of course, there's also the question, how can we build adaptive systems which keep maintaining their beliefs and updating their beliefs using new information they observe and obtain during their lifetime? That's not an easy feat to achieve, but I think with NARS we have major aspects of this capability covered, and we will see how this plays out. Overall, for evaluation, it would be good to have this like data sets which can show long-running open-ended Q&A sessions. So not just like in most Q&A data sets that you have a piece of information and then a question about it, and then you move on to another example which is completely unrelated. But we really want to show long-running open-ended Q&A experiments, and we have made major progress in this regard. Additionally, we want to address the limitations which, for instance, this limited context window I already mentioned, and we want to support this long-term operation. And overall, clearly this will be useful for autonomous systems which are supposed to be able to be adaptive and learn in a lifelong way. Overall, there's also this ladder of intelligence which we can see here. Maybe better. I want to take over.
Okay, I will take over.
Yes.
All right. So even though this is mostly about the combination of the NARS and GPT and other different ways we actually were able to combine and provide different results and compare them, and you will see which one works best. So we decided to include here some introduction about intelligence and the NARS itself, because NARS actually is the main component which allows the breakthrough in the long-term memory in terms of combination of NARS and GPT. I'm sorry, 1 second. Is it you?
Oh.
No, then never mind. So here we have the ladder of intelligence. So say on an error of intelligence. So how we do define intelligence? What do we think about intelligence? So other coffee machines which like have a pre-programmed automation are really intelligent. So currently probably not. Just a branching there. But then we go that other self-driving cars are intelligent. Well, they are also pre-trained, where they are pre-programmed and they are automated, but they still cannot reason in the real time to the main extent. So now we're going to some of the live creatures like insects. Are they intelligent? Well, they add to the previous layers, they add the adaptation, which is one of the key aspects of intelligence. And then we go even further, we get the mammals, birds, animals, and they already can reason to avoid some situations, for example, or life-threatening situations. And at the end of that, we have the humans, us, basically, we also can reason and add language, natural language to communicate and do all of the intelligent things. Can we go to the next page? And given this understanding of intelligence and ladder of intelligence, we actually have come up with a definition of intelligence. And before that, I would have to mention what is an AIKR, is basically an assumption of insufficient knowledge and intelligence. And it says the following. So whenever one have all the knowledge available and all the resources and time, unlimited time to solve it, so any problem on any domain is solvable. However, it's not the real world scenario. You never have like unlimited number of time to solve this problem, and also you don't have the unlimited resources to solve the problem. You always have to give the reasonable response or reasonable answer, giving some limited time, and you also have some limited resources. So this actually, that what NARS is good at, and we can define intelligence, something that according to us, in particular Dr. Puang, is that intelligence is the ability to adopt. It's the most importantly to adopt under insufficient knowledge and resources. Such that intelligent species in nature, they can very quickly adopt. They don't need to be retrained for hours or days, like with huge power resources. They, from one or two examples, they already can adopt. And repeated mistakes are often fatal for them. And this is basically provoked by the evolution. Let me go on the next one. Now I want to introduce that NARS, which stands for Non-Axiomatic Reasoning System. And this is the main general purpose reasoning system, which is we've been working on for many years, actually, about more than 3 decades. It's a long project. So one of the main benefits, it operates using the non-axiomatic logic. So it's a term logic. And it has the formal language called NARS. And also it operates under assumption of insufficient knowledge and resources, which allows for finite processing demands. It actually, system always has to be open, because any new task, information or goal or planning has to come at the runtime at any time. You never know it. And also it operates in the real time and treats time as a real-time operation, which is one of the main, if not the main important aspects of the system. Now I mentioned about now. No, next one. We just talked about it. About now, and this stands for non-axiomatic logic. It's very important, as I say. Actually, one of the major, I would think, advancement of NARS is that it has the terms such as they're like cat, dog, animal. So those atomic terms. Also, terms can be compounded to the very dense and difficult structures. And also it has the statements. We call them narcissist, right? And here we have some of the examples of the statements. They can be compounded. They can be, one second, okay.
Some issue here with
Some issue
with numbers.
Right, actually I don't have it here. Okay, so forgive us please for some symbols over there. I know some Unix input doesn't have the correct encoding. This is actually the same. If you can see the cat is an animal, cat error animal, inheritance animal, it's exactly the same error over there. That means for the inheritance. So
should also be an error.
Right, should also be an error. And the idea is that similar to the language, to the English language, for example, where a cat is an animal, we define the inheritance relation between the cat inherits animal, Garfield, which is the name, which is the instance, is an animal, and then the cat is mewing. Cat is what it's doing is mewing. Instance property relation, basically. Then we do have the implication there, also important. Lighting implies thunder. And then we will create compounds using those simple terms and statements to achieve the enormous complexity. As you can see in the last, is a nested narcissist statement there, which like if switch is on, then light is on, right? And that's actually another very important aspect, is that now provides ability to define uncertainty. And we define the uncertainty through the evidence. And over here you have few of the very simple terms like positive evidence, negative evidence. As you can see, W is evidence and W plus is positive evidence. W minus is negative evidence. So we define two truth value, which is very important, which is degree of certainty to the certain belief. So how much I can believe that whatever system answer me is true. That's what it is about. It's very important. If I don't have that, so everything basically becomes either the belief is true or false. The frequency and confidence are two of the elements of the truth value. So frequency is being defined as the positive evidence divided by total evidence, and total evidence is the positive and negative evidence. The confidence defined is very similar, not the similar, they have similarities with the probability though, is that confidence in defined total evidence divided by total evidence plus a constant. And in this a practical application of the constant is 1. So what does it give us? So for example, if we have like few coin flips, at this the total evidence we have, so basically how confident we are if that's the coin is fair or not. And if, for example, we have thousands of coin flips and we have just half of them we have correct heads, so then the frequency is about 0.5. It gives us that confidence is very on this. The later case is way higher than in the first case. So from the 1,000, we can infer that 500 basically are the heads, and we can define and we can really assume that the coin is the fair coin.
Mhm.
Now it brings us, before it was kind of very little theoretical overview that gives you information that NARS, it's also about evidence and uncertainty, and also real-time reasoning. Now this is an implementation. So OpenNARS for application is an implementation we use. It's our so far most efficient, and we run multiple benchmarks. We have multiple implementations first of all, but this one is our most main implementation because it's most efficient and provide a better benchmark scores. So this is the pragmatic design which follows the NARS theory discussed just a few slides ago. It has it utilizes the non-axiomatic logic. It provides the real-time learning, and it's designed basically to reach goals, establish sub-goals, and proceed with planning, etc., etc. So it is capable of controlling intelligent agents, which is mostly robots, and can enhance for autonomy. Also very important that the OpenNARS for application actually support interfacing with the state-of-the-art deep learning models, which we will see it today. So it's we can easily connect either the visual channel for the object recognition or like GPT channel, language channel, whatever NLP channel, to really create a more complex system out of multiple approaches. Can we go? Okay, Unix.
I can actually derive this is also the case here.
No, it's not.
Because this is Mac and this is Fedora.
Sorry for the slides. We have multiple systems in the running in the memory virtual systems.
This looks better.
Way better.
Fedora doesn't run.
Right. So this is the very high level architectural overview of the OpenNARS for application. As you can see, it can learn from the real-time events, and it's a real-time without interruptions. So then it can extract sensory motor contingency, use them to plan ahead, create planning, and create sub-goaling, and this really enhances the autonomy of the intelligent agents. It's important to know that if you can see there, first it's a very high level. Of course, it's way more. And next slide will tell you is that it has a concept memory unified design in main cases of. Then it has the temporal inference, procedural inference, declarative inference, all types of inference actually. Can we go there? And this is the more detailed overview of the ONA, OpenNARS application. As you can see, the conceptual memory is a little bit advanced there. So we have some priority queues, and we have their declarative reasoning, and we call them the first low-level logic levels. Nulls 1 to 6 is a declarative reasoning. We have the temporal reasoning for the null 7 is a separate component there. Then we have the procedural reasoning, which allows us to execute operations, pursue goals, and do sub-goaling and also planning, which improves the autonomy of the intelligent agencies. And all of them connected through the unified memory, such that it operates in the real time on a cycle-based, data-driven aspects. Can we go there? And now, basically, only few capabilities here in sake of time. so there is a conceptualization such that information is conceptually represented. There is semantic, spatial, and temporal relationship in NARS. So there is the memory is there is a long-term memory, there is attentional focus, and there is contextual memory. Very important that this has the adaptation capability, I'm sorry, in an unsupervised way. So it actually can learn using those mechanics. We will not talk about now, probably Q&A we can explain. Such in unsupervised way, using one shot, the NARS can really adopt similarly to the living being to avoid in the future or do something different as the next iteration comes. And of course, which you mentioned, so that handles uncertainty and contradictions and answer and explain questions and answers, which actually was further improved with GPT integration. Shall we speak about this?
Oh, yes. So what we especially addressed with this particular project now is how can we actually integrate transformer models, and especially one particular tab, which is the GPT models, generative pre-trained transformers, because they are so successful with dealing with natural language. And they are not only transformers in general, not just successful in natural language, but they are also widely adapted in other domains. They are very effective in vision, in the vision domain as an alternative to the convolutional neural network, actually. And they can also handle multimodal input. So it's quite promising to investigate to what degree we can integrate these models and make use of them effectively. That's about that, and we have explored multiple directions in this regard. We have like a baseline system where we simply where we simply use GPT, and where we clearly observe, of course, the contextual window size limitation, that in context learning has no long-term effect on the weights of the system. So everything which goes beyond this context window will be essentially forgotten. And what's from a reasoning perspective, if we look at what reasoning actually is and how humans utilize it, there's one very important aspect of reasoning which is not at all captured by GPT models. That is, when we make conclusions, we actually store them. We can store them in our memory and reference them in a much later stage for various purposes. That's a very important aspect of reasoning. That's called forward chaining. It's a way for us to derive new information from existing information and then keep this derived information for later use. It's a very essential component of reasoning systems, which is not answered by GPT models. In most data sets where reasoning is investigated, it's usually of the form you have of a few inputs, and then you have a question, and then you forget about it, and then there will be a completely new set of inputs and questions. So it's not really reasoning in the traditional sense, as long as conclusions are not stored for long-term usage. That's a key takeaway which needs to be addressed. Since question answering is only a very minor aspect of reasoning, if we look at reasoning in animal kingdom, the major reason is actually for decision making. We try to reason in a way which lets us deal with novel circumstances in a way which we couldn't otherwise do, and in order to gain survival advantage, essentially. And in this project, we have explored intermediate stages, so we did not simply go from GPT to combining NAS with GPT, but first we tried to address this contextual window size limitation. And one way to do this is to make use of embedding vectors, which GPT models can provide by taking out hidden layer activations. And then essentially, if you have similar inputs which encode something which is similar in meaning, you will get similar embedding vectors which are close in this high-dimensional space, essentially. And that's what we make use of this, what we labeled LTM GPT. Essentially, we use embeddings for calculate them for all the input sentences, and store them in a long-term memory together with the embedding, so that later when we ask a question to this LTM GPT, we can pour out the sentences which have a close embedding from this long-term storage in order to feed it to the prompt and be able to answer questions which it otherwise couldn't answer, because otherwise the contextual window size would kick in. So essentially, you selectively choose items from long-term memory based on embedding similarity. And so you can, with this system, you can address long-term record via this embedding vector functionality. There are still other issues which are not addressed by this simplistic approach. You can store sentences, but you don't really have beliefs or updates of beliefs. For instance, if I say something like, the cat is on the table, and then I say the cat is under the table, then the system will pretty much be confused, because at one point it was on the table, then under the table, without any notion of time and happenings of events. It's pretty much lost and will say there's contradictory information about whether the cat is on the table or under the table. But if you have a system which can track time and has a notion, an intrinsic notion of time, then you can have belief updating. You can know, system can know, okay, the cat is now under the table, and derive evidence that it's not on the table anymore, and update the beliefs accordingly. And that's not an easy feat. This is not addressed in this system at all, even though it can store sentences for long-term use. It's not able to update beliefs. So it's still effective for question answering, where you simply wanted to remember a lot of information in form of sentences and then ask questions about these sentences. This it can do effectively, but once there is any contradictory information or some temporal dependencies where beliefs need to be updated accordingly, then this system will fail. So this led us then to the third option, which is to combine NARS with GPT. So what we have here, we have long-term belief updating with proper evidence accumulation principles, which have been developed in the NARS project over the last decades, which have turned out to be very effective for this kind of belief updating, which we require intelligent systems to have. And the good thing with this approach is that the inference the system will make is always correct according to the available evidence the system has collected. So it will not make faulty inferences, but it's always justified conclusions based on the evidence. What's also good with this system is it has a seamless integration with sensory motor, but we will, today in this talk, we will not go into sensory motor. This is future. We hope at the AGI conference, we will already show you what we can do with sensory motor plus language abilities together, but not in today's talk. There's still also some issues in this system, like we will see it makes use of a form of a relation extractions from complex sentences using GPT itself, and some information sometimes gets lost in this process. So overall, we have these three systems. So one is just GPT, you feed in sentences, you feed in questions, and you get just some token sequences in return. That's like ChatGPT essentially. Then this GPT with long-term storage, you feed in information, you calculate embeddings, and you store the sentences together with the embeddings in the database. So when you ask a question about it, we can now calculate the embedding vector of the question and pour out items from this long-term storage which have embedding vectors which are close to the question. And this way you can then pour them into the prompt, and GPT can then answer accordingly. So that's how contextual window limitation can be resolved. But we have here with NARS, we go one step further. We take in the complex sentences, we take GPT's ability to handle natural language to give us simplified pieces of the complex sentences, which we can directly translate to NARS, which is the formal language of the reasoner. and the reasoner will then derive additional information, and the information it derives together with the input information will again be there will be an embedding calculated, and it will be stored in this memory. So we have a memory which has the NARS, which is the formal for representation, which also comes with a simplified English representation and embedding vector attached to it. So again, if you ask questions, this time you have the feature that when you ask questions, you now get actually items from long-term memory again, which are related to the question, but this time you actually have belief items from NARS memory. And that's a major thing. It means that when you ask a question, you are essentially asking a question about the memory of NARS. And that's a major feature, because it means all the memory updating features, belief updates, which NARS is able to do, and reasoning capabilities are captured. When you ask the questions, all the derivations the reasoning system made are taken into account, which leads to a seamless integration where the reasoning system can derive new information and you can ask questions about it. The way this is carried out, we essentially prompt GPT to take sentences apart into subject, verb, object triples, essentially, which we call relation claims. So if I say Garfield is eating a mouse in the garden, then it will say Garfield eats mouse, Garfield is in garden. So it will essentially build multiple triplets which correspond to the information in the sentence and which cannot be further divided. If you make the pieces any smaller, you will lose information essentially. So the idea is you will always translate the sentences into all the information that is in the sentences. And there are also negated versions of this, so you can have negated relation claims. So if I say Garfield is not in the garden, this will also be considered. So GPT turns out is very effective in coming up with this triples from complex sentences. To some degree, it's not surprising. After all, it is trained on natural language. It's supposed to be able to carry out such a translation. And for the questions, if we look again at this picture from here, when we ask questions, we calculate the embedding vector of the question and pour out the beliefs from NARS memory. And the way it's presented to the prompt, we have a place in the prompt reserved for memory items, so that essentially the items which will be poured out from NARS memory will appear in this position of the prompt. And we always ask it, when we ask a question, to answer according to the memory contents and giving us the concrete memory reference. So actually we can also directly check, is the answer the system gives us made up, or is there actually evidence for it? Which is a feature which is missing clearly in normal GPT, where it's not always clear if the answer is made up, hallucinated, or actually has a ground. We have carried out in the meanwhile experiments which are there to measure the system's capabilities, also in comparisons to what's already there. 2016 already there was a task by Facebook AI research for measuring reasoning and understanding in AI systems. It's called Facebook PABI dataset. It consists of 20 reasoning tasks, different types of tasks which require different types of reasoning. For each, there are 1,000 training and test examples, and the dataset includes both, or requires both deductive and non-deductive types of reasoning. And there are also various forms of reasoning. You need spatial reasoning about spatial information, temporal information, and other declarative information. And this particular dataset for Facebook focuses especially on short-term question answering. It's part of the Helm challenge, holistic evaluation of language models by Stanford. So it's part of the set of data sets. I can recommend it because it's really a good way to measure reasoning abilities, at least some of the subtasks which are included there. Additionally, Peter Voss from igo.ai has given us a int-inf benchmark, is an incremental question answering benchmark, which shows input which is typically provided to a personal assistant, generic personal assistant with over 1,000 lines of question input information and 652 questions associated to them. Also includes spatial, temporal, and other declarative information. The difference to the previous dataset is it focuses on long-term question answering. So the system is expected to remember and answer questions about information which was entered a long time ago, essentially. The current, somehow, don't know it works. So currently we can present you some metrics. For instance, this Barbie task comes with different reasoning types or reasoning tasks, essentially. It's essentially a collection of multiple data sets. They don't even have the same format, but there are different tasks included. And this QA16, which is part of this Barbie data set, there are a total of 899 questions, of which currently NARS-GPT gets 655 correct and 246 incorrect, which leads to a ratio of 0.73. And we compare this with base GPT, if we just fit this, it's a task which does not require long-term memory, but it's a task which requires inductive reasoning abilities. And here we can show a clear advantage with 73 questions being read versus 32 with GPT 3.5. So that's one thing where we can show clear advantages. To give you an example, what such abductive reasoning task looks like, here is an example. There's some wrong headlines in there. But let's say we know that Greg is a frog and Brian is a lion. Bernhard is a swan, Brian is gray, Greg is yellow, Lily is a frog, Bernhard is yellow, Julius is a lion, Lily is green. What color is Julius? If you look, Julius is a lion, but there's nowhere is mentioned what is the color of lions. But you see there's let me see, there's Brian. Brian is also a lion. Brian is gray. If we don't know anything else, then probably Julius is also gray. ChatGPT answers, based on the given information, we know that Julius is a lion. That's right. However, we don't have any information about his color, so we can't determine his color from the given statements. NARS-GPT, Julius is likely gray according to the memory item with the certainty value, since NARS had this abductive reasoning according to which this conclusion, which is actually justified according to the data, is made. So NARS is really good at this kind of abductive reasoning abilities, where you cannot be absolutely certain, but you still have some information which can give you the answer. Additionally, there's this int-inf dataset, which is incremental Q&A. This we especially did just to show whether this approach can get away with the contextual window restriction, whether how well we actually perform in this regard. So there are 652 questions in total. We got 424 correct, 228 incorrect. In this case, a correctness ratio of 0.65. So in this data set, it's more about recalling information, which is asked about over a long time period, or provided much earlier. And in this case, yes, we get 65, which is still way beyond the 11% of GPT 3.5. But it's in this case, of course, it was a low-hanging fruit because the contextual window restriction kicks in, because this int-inf dataset has more than 1,000 inputs, which is simply way beyond the contextual window of GPT 3.5. So in this case, we are aware we will need to carry out additional experiments. In the meanwhile, it's really a quickly moving field. There are some repositories, you might know some of them, like LangChain, AutoGPT, Baby AGI, and various forms where they try to equip GPT models with long-term memory and vector storages. So it will be a lot to do for us to also compare with the other models. But it's very important what all these models address is the issue with the contextual window restriction. Another thing which is a quite hot topic more recently is how can we actually correct the beliefs of a system? And what if the system believes something and we don't agree with it? It has been trained on a large data set over internet, but it comes up with hallucinated answers which matter for the domain we want to apply the system in. Let's say we are a restaurant owner, we want to provide an interactive menu to our customers, but for some reason the system hallucinates, like GPT 3.5. What is kefir salad? It says, I believe kefir salad is a German salad made with green beans and potatoes, certainly 80%. Complete nonsense. It's not, it's Austrian salad. And it's also not made of potatoes and also not made of green beans. So I corrected NARS-GPT. I said kefir salad is an Austrian salad made with runner beans, onion and pumpkin seed oil. And the next time when you ask it, the beliefs will already reflect this knowledge you have input. If you ask it what is kefir salad is salad made with runner beans according to memory item. So it also references the right memory item and gives you the certainty values. You can of course ask follow-up questions: in which country is it made? It correctly says in Austria. You can also ask for the ingredients. You get here an interesting answer. According to memory, kefir salad contains runner bean and onion. And pumpkin seed oil may also be ingredient with the certainty value. So this memory is essentially NAS memory. So it really gives you the entry of NAS memory with the related confidence value attached to it. So you can really check if this is actually factual or made up. Slide debug, and that's essentially all we have here for now, but we can actually give you a live demo of this system just to show you some interactive demo and to give you some idea of what you can do with the system. But maybe before we go there, I want to get to some takeaways. And maybe actually, should we do a demo first, Peter?
Yeah.
Demo first? Yeah. Okay. Then maybe we will first do the demo and then we will get to the
and also someone can type in chat questions. I'm not sure this is not pre-programmed system.
Mm-hmm. Good point. I hope this
So anyone can type any question or any declarative knowledge into the chat, and we will just input it there, copy and paste it. You would be able to basically somehow to interact with the system yourself. Just the way you would see, so it's not something like pre-learned system for certain things, or like pre-coded or pre-trained.
I hope I have the right API here, else I need to copy it. So currently system memory is empty, but let's first try if even, let's say there's a cat called Garfield. I think the API key is not right. Actually, it was right. I interrupted it. Okay, good to see. So it's actually
it just constantly writing to the mem file. That's why it's removed. Just to, as a clear it.
Mm-hmm. So we can, for instance, just enter some sentence, and then we can, you see, it generates some statement like here Garfield is on chair, and we can actually also look into the memory of NAS just to see how this is represented. So it says, here it says that Garfield chair is on. This is essentially the formal representation of this sentence, which has been created from this input. And you also see some additional information. You see occurrence time information. And you also see the system's certainty about this statement. And the other values are not too important for now, but most importantly, you have this occurrence time information, so it has a notion of time, it also has a notion of certainty, and you have this formal representation under the hood, which allows for proper reasoning and efficient reasoning to take place. So if we, for instance, say Garfield is a cat, then we can then, for instance, look at memory again. And now you see it derived something like cat is on the chair. And so if I would now ask, is there a cat on the chair? It would give me the memory item. It would say that yes, this is the case. And it gives me the certainty value that is associated with the statement. Somehow the zoom window is on the way. Thanks. So you have this property that you will always get the memory references. We can also look at how this looks like from the prompt perspective of the system. You see here, there's a memory item I equals 4, which is really this item here, which is represented, which also has this natural language representation attached to it. So this formal sentence also has this natural language sentence cat is on chair, and with confidence value of NARS. So essentially you can just write information in English. It will correctly translate it to the internal language of the reasoning system. It will make proper reasoning steps and update its beliefs according to the information you entered. So all the certainty values will reflect the evidence you actually provided. And when you ask questions, it will actually pour out the relevant items from the memory of NARS to answer your question, which you gave in natural language. And we will later come to the Q&A. For the certainty values for now, because I just saw the question, we can look at the calculations later again on the formula. We have only briefly shown it on some of the slides. But essentially the confidence value, if it would be close to 1, you would essentially have extreme amount of evidence. It can never get to 1, because 1 would mean infinite amount of evidence for a statement. Essentially. So that's about that. What's also interesting is you can also, because there's also GPT, so yes, it will always reference memory item of NARS, but it can also do some additional things, which, for instance, how many things are on the chair? Okay, that's an interesting answer. GPT is not really good at counting, I have to admit. So this is also something which we better let the reasoning system do, but but we can ask which things are on the chart. Maybe this gives us an idea of why it said 1 or 2 things. Okay, so it counted both Garfield, yep, and we said Garfield is a cat. So it also says a cat is also on the chair, which is right, but since Garfield is a cat, we would usually not also count the cat, right? We would usually only count Garfield. But you see, it gives you the correct pieces of information which led it to this conclusion, which is really good from an explainability perspective, because you can actually check why did it give you this answer, which is not typically the case for GPT, that it can really give you concrete memory items, which you then can actually check if they are actually there and how certain they actually are. And so that's a quite neat feature. And we can also So currently there's Garfield on the chair. So where is Garfield? Garfield is in a chair. Yep, that's correct. We can say there is also a table. Maybe we invent some scenario. There is a plate and a cup on the table. We can, for instance, ask how many things are on the table and what are they? A plate and a cup, at least 2 things, yeah, at least. True, there might also be other things which on the table which we did not yet mention, also true. And at least the plate and the cup. And we can, of course, also introduce categories. We can say plates and cups are both containers. There, tapped too fast. Are there any containers on the table? You can say the plate is blue. What is the the cup is black. So you can just describe things and continue asking questions about it. Can still ask where is Garfield from before. Hopefully he's still in the chair according to memory, according to NAS memory. So that's still there. But it can also be dynamic scenes. We have, for instance, let's say, okay, maybe there's another item. Let's think about some situation. The dog has the spoon. Where is the spoon? Okay, maybe with the dog. Yep, that's true, isn't it?
Chair is under.
And now I can, for instance, say the human has the spoon now. Spoon currently. The human has the spoon. So this is what belief updating can get you essentially.
Actually, there was one ask for who input some sentence. Chair is under the table in the chat.
Oh, who inputs it?
If you go to the chat, I forgot.
Can check here. But if you say chair is under table, will it know that Garfield is also under the table, or that the plate is over Garfield? That's a good question. We can try. So,
Not typing.
if we say the chair is under the table, and the question is, will it also know that Garfield is under the table? This is a good question. It needs some background knowledge. Okay, it's where is Garfield then? Okay, it's maybe Garfield is so large that he's not under the table. Yes, sometimes some of the conclusion you expected to reach will also demand some additional background knowledge, like, okay, chair, maybe if there's...
Distinguish the chair and the chair.
Is it distinguishing between a chair and the chair? To some degree, it can distinguish between instances and a general category, but it's a tricky aspect, which is not, I think, not yet poorly handled because currently the way we extract relations, or we prompt this GPT to extract triples of the sentences, does not yet fully extract all the information from the complex sentences. So there's still work to do to make sure that all the information in the sentences is properly conserved when translating to the reason as representation.
Where is the table in relation to Garfield? Another question: where is the table in relation to Garfield?
You can ask, but I'm not so certain of it. The table is on which Garfield is sitting, okay, but that's not actually the case, right? But the good thing is we can correct it. Garfield is not sitting on the table. Where is Garfield sitting? So what color is the plate? Did we tell this? I think so, right? Okay, blue. What colors do containers have? I think we also said cups and plates are containers. So, for instance, here we never said that the color of containers are blue, but we had instances of containers, and some of them, if some of them are blue, it will essentially gain some evidence that this is also the case for the general category, and that cups are black. It does not remember. I'm not sure. What is the color of the cup? It should, but the plate was blue. Oh no, was the cup blue or was the plate? We can actually check what we wrote. We said the cup is black. Okay, so that's maybe. What is the color of the plate? Okay. Maybe it forgot this somehow, that the cup is black. The cup is not blue. Or do I contradict myself? What did we really write? We said the cup is black, and we said the plate is blue.
Ask it.
Cup is not blue.
Okay, then.
But
what program are you using? Valiant program. It's Genie.
This program is
It's basically text editor.
a text editor which is available for Windows.
I should believe the copy to be blue.
When it's believed, you can actually check the memory contents.
What AI program? It's a NARS with a GPT. That's what it is.
Oh yes.
That's
essentially what we.
Yep, memory contents from NARS and the translation and similarity from the GPT, similarity calculations.
Yeah, it was kind of having the same. It's sometimes a little difficult to envision when NARS stops and GPT starts, and that. But when you do the memory command, that's a dump of the NARS data state of memory, correct?
Yes, or part of the memory.
Yeah, the most important ones, I would say.
Yeah.
It's a difficult computation of how to compute the important ones, but the most important ones. And recent combination of important and recent.
It seems like you could just kind of run them in parallel to a certain extent.
Mm-hmm.
It wrote twice cup to be blue. Shall we restart maybe?
Let's see.
So we have a contradiction evidence, that's what it is.
Yes, that's still interesting. Going on there.
So
But
just to clarify, when you type something in at the input prompt and you hit enter, that's fed right to GPT, correct? Pretty much.
it depends.
Can you go to that over here?
I can look at this later too. I just
No. You can explain now.
Oh yes, so it
Briefly.
depends. So if a question is asked, it essentially calculates the embedding of the question, and it pours out the beliefs of NAS memory which are related to the question, and then answers according to these beliefs. And if you enter new information to the system, it will essentially pour it apart into multiple relations, which are then needs to which are then fed into the reasoning system. So it depends. So new information essentially goes to NAS directly, and if you ask a question, it will pour out the beliefs of the reasoning system, which are close to the question you ask, essentially.
okay, I see. And it kind of it follows the NARS paradigm of you've got the a judgment input or you've got a question input. So
Yes.
it's split like that.
Mm-hmm. Yes, exactly. And maybe
Shall we do the cell phone demo?
or maybe we will finish this first, because
Okay.
I think I will need some time to set up the cell phone demo. There's just where is it? So maybe we will give some takeaways before we go on with this. So what we can already say, even though it's an early prototype of this system to combine GPT with this reasoning system, but we can already say it's quite effective to use GPT to extract relations for the reasoning system. That this worked quite well so far, even though it's not complete yet. But also what we already saw to some degree is this ability that you can just keep feeding new information to it, and it will essentially adapt its beliefs, which is not always in the way you would expect it. It's not always not always intuitive how it updated its beliefs, but you can at least correct it. So if the system believes something where it has found some evidence for something you don't agree with, then you can essentially say, no, this is not the case, or this is different. And the system will immediately update its beliefs accordingly. So this is a convenient feature. What also has been what we can already say is that the inference control strategies which we have developed in the NAS project turn out to be very practical for reasoning on natural language input information. So the inference control strategy in NAS, for many years it was actually one of the points which were hard to get right. And I think what we can already see is that the inference control in NAS works pretty well at this point. And so this is not the bottleneck anymore. But we also have seen some of the reasoning performance which increases for certain reasoning depths on natural language input. So you get actually improvement by using NAS as a reasoning system here, especially when you need abductive reasoning and when you need incremental knowledge updating, then you get advantages using this system. Additionally, I think it's generally interesting direction to have AI systems where you can have incremental Q&A sessions. Essentially, you can just keep feeding it with new information and continue asking it about it and correct its beliefs and essentially let it develop its own experience of own set of beliefs of what it has experienced. So that's now possible, which is quite neat. And I think before we will dive, maybe we'll give a short phone demo, but I'm not sure how long it will take me to run it. So maybe we will answer a few questions for now, in case there are any urgent questions.
Okay, does anybody have any questions? I don't, can you guys unmute if you or type in the chat if you have one? I may not have, I tried to mute all at the beginning and it didn't work so great. So I don't know if you can actually unmute, but I hope so.
Let's see.
Oh, I think I have everybody still. Okay, I don't know. So. Well, it looks like there's a couple of questions that have shown up now in the chat. So I don't know if we've got one from Jeremy. Are the predicates like, is it sitting on treated as atomic in NARS-ease? Or are there built-in entailment relations with terms like on, sitting, temporal, etc. terms?
That's a very good question. What we already have in this is that it can essentially relate like compound terms to its components. There's some structural reasoning which NARS by itself does, but there's also in the input encoding which GPT, like in this case, is sitting on, might initially be atomic. But if you have like multiple, sometimes it creates multiple relations, and so you might have over time you might have cases where something was sitting on something, and then you have cases where something is standing on something, or something is just on something else, and then the reasoning system will automatically build a taxonomy of relations essentially. So essentially there cannot just be inheritance among arguments or specific objects, but there can also be special cases and general cases of relationships, which is really helpful here. What's also possible for the system internally, which we did not show today, is to build compound terms. Like if you have sitting on or standing on, this can actually be represented as two compound terms in the system, which is essentially two relationships which are closely related, but still variations essentially. Are still variations. So yes, it depends on the input encoding essentially. But even if there's a compound like sitting on, you can also still relate it to other relations like being on or standing on and so on.
Mike, I think you have a setting in the security saying that it's not allowing anyone to unmute themselves. So if I try muting and unmuting it, it doesn't work. So I think
I can hear you, so it looks like it worked.
you unmuted.
You're right. I see what you're talking about. Yeah. Okay. Everybody should be able to unmute themselves now. Sorry.
Hi, everyone here. Yeah, I just, yeah, I can do it right now. Can you hear me?
Yes.
Yes.
So thanks for, sharing your information, and I'm new here in this group, but this is my first time. And just try to understand your tools. So, I have a little question. This is like the GPT and your GPT is totally different than, or there's some similarities or some differences. So I can my field is looks like cybersecurity. So I'm just trying to do something or creating something about how can I write a query or any kind of language? Is there possibilities?
Can you repeat, please, the last part? Sound was distorted.
The sound was distorted.
I say, I mean, if I try to use this concept of your language or your GPT, so can I write it down like any kind of query for my like whatever? Because my field is cybersecurity, so I try to do some query in SQL or KQL in the cluster query language. So it's possible to do this.
I see what you mean. Like to have some kind of case where you have some knowledge and you want to query it in some sense.
Sorry.
Like situations where you have like some knowledge in a database and you want to query it with natural language. Is this what you're asking?
Yeah, I mean, you can say natural language, but I'm talking about especially the I mean, the searching language like SQL or KQL or like Splunk query language or cluster query language. So within cluster query language, so can I write it down any kind of query for like, for example, I try to find out or I'm doing some investigation, any kind of alert or incident in security operations center. So I'm trying to finding out some things or artifacts about within the incident. So is it possible to write it down any kind of query by using this ChatGPT?
I think we're talking about if you can query the information. If there is some answer, can you query the memory so I should understand if it's there? That was the question, right? How you want, for example, debug, see why it's answered the following. That was the question, basically, correct?
Yeah, you can say, but like for example, we already have like in ChatGPT, they already have some, the
Yes,
language.
yes. The thing is, it's the whatever the explanatory part, if I could call it, does not come from the GPT itself. So it comes from the NARS memory.
Okay.
And yes, and the NARS memory is the complex mechanism of keeping what's important, what's recent, and balance of them. And yes, you can query exactly and find out why you have this certain answer. But
Okay.
it's very actually explainable AI in that regard. However, sometimes there can be like forgotten items because it's real time, and my NARS memory can be overflowed also. So it's forced to keep something important and forget something. If that's what you're asking. But yes, there is the possibility to really trace why the GPT answered you the following, given you submit the NARS memory in the prompt. And that's what the actual process is doing. It's submitting the part of the snapshot of the snapshot of the NARS memory in the prompt, within the prompt.
Okay.
If that answers.
I mean, yeah, I did, but okay. So how can I access the NARS memory or your GPT? Is there any option or any link so I can use?
There is so far so far it's just through the terminal. I think it's for the future it can be enhanced, doing some put it on the cloud, then vectorize DB, and then have some API calling it, visualizing it, or doing some even like same transposition as SQL DB can do. But as of now, we just doing it in the RAM because it's basically it's the first POC, and we have that command just to print the snapshot what we have, or maybe to query or find what is there. But in principle, the next phases we're thinking about it, we can have like multiple databases in different forms. And that can be saved to the files, can be backed up and can be traced. But that's like next phase 2 or phase 3, whenever there is already a practical application of that. For sure, it has to be done. But so far it's just POC, and if you go to the diagram number 3, that one we create. So you can see that basically embedding DB can be on any forms for whatever time frame can be saved somewhere, if that's the case. And this you can investigate why, for example, as Patrick was doing in the real time, why it answers that Garfield is on the table, even that chair is under the table, and before that was a contradictory that Garfield is on the chair, which is under the table. So this is very handy for the investigation. That's one of the big hit actually. Whenever not available with the plain GPT as of now.
Have we got any other questions? I see Nino put something in the chat. Nino, do you want to ask your question or?
I was just wondering, why does it, like, where does it get the mishap of believing that the cup, which was said to be black, turned blue? Like, this can either be at the inferencing stage when it thought things over and thought now the cup must have been changed to color, or it is assuming that the colors are not alternatives, so you can be both blue and black, just like you can be black and round, or blue and triangular. Or it is perhaps a mishap when you're translating from GPT to NARS. I can imagine also there's something happening. Like it looks really strange to me because I have seen such demos which Patrick is sometimes showing and it is always very reliable. So that it's an inferencing error would look strange to me, that it maybe somehow did not capture quite the schematic natural language translation that I could imagine. I was just curious about this, what you think.
I think the second option you mentioned is really fitting, because we learn through our experience that certain things can only have one color. I mean, of course, there are also examples that objects can have multiple colors or textures with multiple colors involved. But it's to some degree when we talk about basic objects having a certain color like black or blue, then essentially it takes some experience for us to learn, okay, the things which are described to be blue are not red, are not green, and don't have any of the other colors. In our particular example, we introduced two objects, as you mentioned, the blue and the black, one being cup and one being plate. And interestingly, and in the moment where we said that both are containers, it also inferred that, okay, maybe containers also have this color of blue, or it certainly also inferred it for black, that there are also black containers. And it takes some experience then to learn that, okay, a particular object can only have one color, instead of treating them as independent properties, where in the moment where we introduced the blue plate, which then propagated evidence through container to the cup, that the cup might also be blue. And as you say, it takes some how to say it. There's like an assumption behind which is things, basic objects typically have one color, and so if we describe it as blue, it doesn't have the other color. And NAS can actually quite effectively learn this, but in this Q&A session, which we have just seen, it essentially started completely from scratch. And you also see this with young humans, that initially when they begin to speak and ask their first questions, it will take some time until the questions they ask are more, how to say, at the beginning they can be quite creative in the kind of questions they ask, where certain assumptions we essentially have to learn through our experience. And that's a good case, that essentially in this case we would like the reasoner to learn that these color assignments are typically exclusive, maybe not always, but typically, and so that it will not begin mixing the colors between the objects of same category.
One thing that I did notice, that when you were adding the colors to the memory, you did mention that cup is not blue. And there was another instance up there where it said Garfield is not on table. The word not was not used, or probably was not saved as a negative scenario, like, not as in disassociate versus associate. So the log back on your terminal said that the association was taken as a positive and not a negative. So I'm not sure if the objects associated themselves with two relations instead of removing one of the associations from before.
That's a good question. Usually, if there's negation, so for instance, we had here this case of Garfield is not sitting on the table. The way it encoded it, at first it looks like it encoded it as a positive, but if you look actually at the truth value of this statement, it actually uses a frequency value of 0, which means that this evidence is completely negative evidence. So NARS essentially has two ways to speak about
Got it. Okay.
negated statements. It can either negate the truth value, like it did here, or it can introduce explicitly a negation of the statement and leaving the truth value as is. So it's essentially that this is essentially NARS' most simple way to deal with negation, that is to have the truth value providing negative evidence.
Got it. Got it. Thank you. Got it.
You're welcome.
Hello, can I ask a question? So thank you for the presentation. I was just wondering, I actually asked a question, how does it deal with the typical problem of when I was 80 years old, my brother was half my age, now I'm 50, how old is my brother? That's on the chat. So, and I'd like for you to maybe test that at one point, but also ask you if you've benchmarked this against ChatGPT and GPT-4, but let's focus on GPT 3.5 and its reasoning capabilities, because with this kind of problem that you have there, so what happens with GPT 3.5 is that it gets it wrong. So if you and can come up with all kinds of questions, but if you start probing it and understanding why it gets it wrong, you eventually, what you realize is that it doesn't understand certain facts about life, like, for example, that the difference of age between two people doesn't change over the course of your life. And the thing is, with GPT 3.5, if at one point you go there and say, I did this experiment, you go there and say, actually, add this fact to your knowledge. And then you ask the same question, he gets it right. So it means that GPT 3.5 is also actually suffering from the same problem. It's just that it seems that in many instances, it just doesn't have access to enough facts. And when it's given those facts, it actually reasons very, very well. So, it would be interesting to have a benchmark that compares NARS to what just GPT 3.5, but with proper prompt engineering.
That's a good question. And you're totally right that also the answer quality will often depend on how well the prompt is designed. We also observed this in our comparisons. We made sure that we feed the same prompt to both NARS-GPT and ChatGPT, so to exclude any adverse effects from differences in the prompts. But at the same time, we also try to come up with prompts which improve the answer correctness rate for both GPT, for GPT baseline, and also NARS-GPT. And what we can say so far is that there are certain types of reasoning which GPT seems to be pretty good at. Like deductive reasoning is surprisingly good, so I totally understand that now it's widely explored whether GPT models can do planning and so on. It's very justified since they really have shown that they can deal with deduction to a large degree. But there still is a major issue when you get this, you can let it answer a question using or giving you the impression that it applied some kind of deductive reasoning. But the thing is, it cannot remember the conclusion it made. It can only remember it as long as the tokens it generated are within its contextual window. So it's, to some degree, it's not really reasoning at this point, because the information it derives is not really stored for later use. It's not really forward chaining yet. But what we tried also with our system is to get around these limitations, and maybe, and I hope so, that the machine learning community will also figure out ways of how proper forward chaining can be realized at some point. But interestingly, if we look at AI history, decades ago, everyone tried to build reasoning systems, and then it became clear, okay, learning systems is a different matter. We need to also be able to learn from data. And now I think these worlds come together again, I think, because now when we can reason about natural language, reasoning becomes approachable again, and we can ask ourselves, can we actually build systems which can draw conclusions and use these conclusions for later usage, where long-term memory and proper belief updating will then play a role. And so far with the GPT models as they are used in most typically, this is not yet an issue. We have the contextual window size. We fit problems which fit into the contextual window size, so it's not a big problem. But once you want to build adaptive systems which learn continuously in a lifelong way, it's a completely different matter. Suddenly, belief updating becomes important. Storing conclusions for long-term use becomes important. You open an entire can of worms, which is associated with how to organize memory and how to form beliefs in the first place, and how to update them, even more importantly. And but it's a really interesting point in history, since we can also now re-explore this idea of, can we actually build reasoning systems which can not just reason on natural language, but can actually accept natural language input and derive useful information from it.
Yeah, thanks a lot.
Welcome.
Did you guys want to, were you able to do a phone demo, or was that, I heard, we've got a little time left.
Yes, I hope I have the red doc in here.
And just take time to set up in the first place.
Yes, I actually have the red doc. There's an app.
Sorry, are you going to do a demo or?
Yes.
Can you take the chance at one point, if you want to ask that question that I just posed about the that problem, the age problem? Yeah, thanks.
Mm-hmm. Okay.
I don't know. Can you either share?
I cannot share the phone screen, but
No. Can you see share here?
The chat.
Exactly. Such everyone would see.
No, you can only see it here.
Okay.
I think there's only one share possible at a time. It's my recollection. Let me,
But you've been able to hear us well, right? So mic are pretty good in this room.
I can hear.
I mean, for the phone, I mean.
Then we can try.
Yeah.
So what we essentially have is we have installed this NARS-GPT approach on the Android phone using an app called Termux. Termux is like a terminal emulator for Android, where you can install C compiler and just run this NARS-GPT the same way as you would run it on a Linux computer or Mac or Windows at some point. And for instance, this system has already learned how to say, I'm running it on my phone since now a few weeks, and it has learned several things about me and about my family and about my friends and working colleagues and so on. And I have also connected it to text to speech, so I could, for instance, ask, who is Patrick? And if we're lucky, we should get a response. Let's see. Could be a bit faster, but I hope it's connected. Interestingly, the speech output does not. No, it does not play. But it said Patrick is a person with a father named Herbert. So, for instance, it knows the name of my father. Just one of the. Maybe I can show the answer at least. I'm not sure if this is.
You're over there, maybe. Oh no?
No, on the camera. So you see the output here. I'm not sure if you can
Camera
read
is
it.
also there.
Huh? This might work, but I cannot see if it's.
Right, yeah.
Right here, can you see?
Yes,
Camera is there.
Yes, but here is also camera.
okay.
Yes. So speech output is currently not.
But why? Can we restart? Can we restart?
I don't think it. I think it's maybe a software thing because I have created some commits on
Okay.
the speech text to speech got lost. It seems. Yes. Any other questions?
There was a question in the chat.
Oh yes, a permission issue. It should not be because it already was running at some point with speech output.
Is there a question in the chat?
Yes, the question was if there's a permission issue.
No. Question to invoke to ask some few questions.
Really, not doing.
I don't see another question about NARS GPT in particular in the chat. It looks like I didn't realize there was more than one person can concurrently share at the same time.
We saw one.
So I set it so multiple sharing is possible, but
Anyway. This we already answered. Huh?
Okay.
This
With my brother, like, I don't remember.
Someone in the chat asked, how does it deal with the typical problem? When I was 8, my brother was half my age.
oh right, that one.
Yeah, how old is my brother? And this is a case where arithmetic becomes important. And one of the advantages if you have reasoning systems attached is that arithmetic becomes easy in principle, or easier at least than having a machine learning model on arithmetic. That's a bit more tricky. But at the same point, it's also interesting to see that with models like GPT-4 that even though it clearly has not learned a general model of addition or subtraction or any of them, it can still add numbers in a very large number range correctly. So it's almost like it learned a part of the algorithm, like it can to some degree deal with cases where the digit flips over. How is it called? Carrier. If you go from 99 to 100, then you need to change multiple digits. To some degree, it can do that. It can do this if the number is not too long. But if you have 15 zeros, then GPT-4 will also fail miserably. So it clearly has not learned a general algorithm, but has just learned how to say. Also, we can say it has not simply memorized. That's also not the case because it can add many numbers which it has never seen before. But something in between it can do. It can change like the last 4 or 5 digits correctly when adding numbers. So if you have relatively small number ranges, it will often do the right thing. Well, at a certain point, it will not, since it has not learned a generic addition algorithm. But still,
Yeah, but I actually, just to jump in, sorry, but I actually think so. From my experiments, 3.5 actually gets it right from an arithmetic point of view. Where it fails was with the facts. So I know GPT-4 gets this question right. GPT 3.5 doesn't, and it's because it doesn't know that that difference in age doesn't change over the course of your life. So it's not it doesn't fail because of its the fact that it doesn't have arithmetic capabilities. I just wanted to see how NARS GPT deals with that. So just
It's a
Oh,
common
so-
sense issue.
I think you're right. In this case, you posted also the numbers involved in your example are relatively small. So I fully agree. In this case, it's not a limitation of the arithmetic which the model has learned. So good question of why it's not doing this properly. But in this case, for this type of example, NARS-GPT does also not add much yet, because arithmetic is, even though NARS is a reasoning system, it's not really built for calculations or carrying out calculations. Even though it has this ability to some degree, it's not yet fully integrated, since we focused mostly on capabilities which we find to be more AGI relevant, like forming categories, working with uncertainty, invoking decisions to reach goals, and so on. But clearly, at some point, clearly humans can do this. So I hope that with on this journey to building systems which can reason, we will at some point get there, hopefully. And interestingly, now that there are multiple approaches, we can try to stay in the neural domain, or we can do like we do, to combine reasoning systems with these models. And so there are multiple options now, and it's not obvious which options will work the best way. But I think in the next years, hopefully we will know.
All right, well, that, I think we're pretty much out of time. Excuse me. We're pretty much out of time, but Patrick, thanks a lot. And thanks to the rest of the team.
Thank you.
Stockholm.
Thank you.
This is really interesting stuff.
Thank
And
you. It was a great opportunity.
well,
Thank you.
thanks a lot. I mean, it's very interesting. I need to experiment around with this a bit more myself.
And maybe as a last point, you can also contact us, of course, and get involved in the project if you want.
Yeah, definitely. I'll check it out. I'll post the video as usual. And just a quick announcement, if you're in Seattle next month, there's going to be an in-person get together. The date, I don't have the date in front of me, but anyway. So I guess that wraps it up, unless does anybody have any final comments?
Next
Nothing?
month is an
Okay.
AGI conference, like in the middle.
Pardon me?
Next month is an AGI conference.
Oh, yeah. Is AGI 23 next month already?
Correct, yes.
Oh, yeah. I'll have to register for the remote, I think. I'd love to go personally. But yeah, AGI 23 next month. That's always AGI. I've always liked those conferences. Okay, so I guess that's about it.
Okay.
Thanks a lot.
Bye bye.
See you.
Thank you.
Bye.
Thank you, Ron.